I wanted to do this lecture on reflections of functions and relations here. What do we mean by reflection? We're going to see here. I'm talking about reflections across the x or y axes. Okay? Now, you guys have seen before that we've been writing our general algebraic relation like this. F of xy equals c, or in this case I'm going to have g of xy equals c. And then what were we doing recently? We were monkeying around with this by putting a multiple on x and y. In this case, I've got what, ax, and I've got by here. Now, you guys remember, so far I've just had a and b being positive, and we were talking about that giving you stretches or compressions in the various directions here. All right? I haven't talked about negative values possibly for a and b, and there's a reason why here. Is if a or b is negative, you get something besides a stretch or compression. You get something called a reflection across the axis. So I'm going to explain that now. Okay? So what I'm going to do here this time, instead of general a and b quite yet, we're going to be thinking of a and b is either plus or minus 1. Okay? Consider a is plus or minus 1 and or b equals plus or minus 1. Okay, in the case where a and b are both 1 would be totally uninteresting. It would be exactly the same relation we had before. Okay, but this is going to be the general idea we'll be looking at here. Now here's what I'm going to do. I'm going to go ahead and just draw a quick sketch of the Cartesian plane with the x and y axes here, like this. It doesn't have to look beautiful or perfect or anything. And you guys remember this is what? First quadrant, come around, second quadrant, third quadrant, fourth quadrant. Okay, so mathematicians go around counterclockwise. So did clocks once upon a time, but there it is. Okay, suppose I have a point, let's say, I'm not taking any particular reason I'm doing this, it's just for convenience. I'm going to be putting this point I'm going to call xy in the first quadrant as it so happens. But it could actually be in any of the quadrants, okay? But I want you guys to consider the idea here of, let's maybe start here with the y-axis reflection of that point. What would the y-axis reflection of that point, what would its coordinates be, and how would they be related to the original? Well, if you imagine taking a mirror and sort of, laying it alongside here like that, okay? And you see, if there was a mirror here, I would have a point reflected in that mirror over on the other side of the y-axis. In fact, let's go ahead and try our best to make a drawing of that reflected point. At this point and this point, they're going to have the same distance from the y-axis, okay? Now, if you guys think about it here, both these points are going to have the same distance from the directed distance from the x-axis here. So, in fact, the y-coordinates of these points are going to be equal. So I can do this so far. There, let's make that look like parentheses. What about the x-coordinates, though? Wait a minute. They have the same absolute distance from the y-axis, but they're actually oppositely directed. So, in fact, if this is x over here, this is minus x over here. So there is the point reflected across the y-axis, okay? Now let's have a reflection across the x-axis. Let's see. So again, we imagine a mirror right there, okay? Yeah, I guess it didn't look perfect. Oh, well, it doesn't look perfect. Anyway, so that's reflected across the x-axis, because if we have a mirror here, we imagine that reflected point down here. What would happen? Do you guys see the x-coordinates would be the same, but the y-coordinates would be negated now. So they would have opposite signs, okay? Now there's one other type of reflection we're going to talk about. It's where I imagine taking, it looks like I got this about right. I imagine taking a line through the origin that also goes through our point of interest here, and I take the point that's on the opposite side of that line from the origin. So this is what we call the origin reflection. This is the origin reflection. I think you guys can see here pretty quickly that what we end up with is in fact both the x and y coordinates being negated. Okay? Alrighty. So you guys want to keep this in mind here. I guess my drawing doesn't look too perfect, but there it is. You guys want to keep this drawing in mind when we're considering these reflection problems. And you know, if you get stuck on the exam or something like this, or the quiz involving this, you guys can go ahead and just scribble this out for yourselves to reorient yourselves and know what you need to do. Okay? All right. So I guess that's enough verbiage on this. I'm going to tell you how we're going to use this and the type of questions I'm going to be asking you. Okay? Let's take an example. Okay. Find the, let's say, y-axis reflection of this abstract relation g of xy equals 0. Okay? I'll just make something up very abstract here, but this is fine. Okay? You guys can see I have my c is equal to 0. Okay? Doesn't matter what that c is, actually. I'm going to show you guys how to do this. Here's what you want to do. When you're talking about the y-axis reflection of that relation, imagine each point on this relation, whatever it is, some abstract relation, some weird curve, okay? You're going to take each of those, reflect those points. So the set of all points you're going to be looking at is the following. Notice that these are, I should say this, let me throw this in. Notice that these are actually what? Reflections of each other across the y-axis. For example, the reflection of xy across the y-axis is negative x comma y, and likewise the reflection of this point negative xy across the y-axis is x comma y. They're reflections of each other. And the same type of statement could be made for all these points, couldn't they? Okay. Now the point xy lies on this relation if and only if it satisfies this, whatever that algebraic condition is. Now I'm going to do a very concrete one here in a minute for you. Okay? But here's all you have to do. Just replace you're doing y-axis reflection. Replace x by negative x and leave y alone. Replace x by negative x, and that's all. So I'm not going to say leave y alone. We'll just assume we leave y alone because I'm not writing anything. So it would end up being this. Okay. There it is. Okay. Now, let me give you, like I said, a concrete example. Okay. Find the y-axis reflection of, let's say this here, x squared plus xy plus y squared equals 3. Okay? This actually turns out to be a certain ellipse in the xy plane. Oops, so refocusing there. Okay, this turns out to be a certain ellipse, so I'm not going to graph it, it doesn't matter. Okay? It's going to be easy here. Now what you want to do is just do what? Just what we said up here. Replace x by negative x. Okay? Everywhere. So I'm going to do this. Now don't forget that you're going to need parentheses when you're going negative x and squaring. Don't go negative x squared. Remember the interpretation? Okay? I'm emphasizing this with putting those parentheses in there. Okay? All right, I hope you all see that. Now, I would rather not leave my answer this way. Okay? I would rather not leave my answer this way. I'd rather simplify this. So you guys see the negative squared, because of that even power, becomes positive 1 in front. So that's actually x squared. This, if I multiply those and rewrite it, and I end up getting that. Okay? Pretty darn simple. Okay, we will be graphing these in a few minutes here. Okay? But in the meantime, let's go on and take this same example here. Oh, let's box in our final answer while we're here. Okay, very simple. Okay, let's do another one. Find the x-axis reflection of x squared plus xy plus y squared equals 3. Okay? All right? Maybe take a second and think about it. Stop the video if you want. What would you do here? Well, come over here. What do you think you're going to do? I'm going to do the x-axis reflection this time. What am I going to do? I'm going to replace what? Y by negative y, but leave x alone this time. So let's do that. Okay? So we'll just say that replace y by negative y everywhere. Okay? Okay, leave x alone. I'm going to use parentheses again. Okay? Make sure you're doing this right. Aha! Once again, we want to simplify our answer. That's ugly there. Get rid of those parentheses. Okay? Hey, you guys might notice here, it's exactly the same answer I had to the previous problem, didn't it? Right? Hey, it's exactly the same. So this means what? This thing, whatever that ellipse is, I told you it was an ellipse, but you know, if you didn't know that, it's okay. But it has what? The same x-axis reflection and what? The same y-axis reflection. Like I said, I will be looking at that a little bit later. We'll be looking at this on Desmos. Or you might try it yourself just for practice here. Finally, let's do this one last one here. What do you think I'm going to do? You know what I'm going to do. Find the origin reflection. Of this thing. Okay. The origin reflection. Well, come back here. What are we going to do? I'm going to, where I see x and y, I'm going to replace it by what? Oh, negative x, negative y this time. Okay, so we're going to do both. We're going to do what? Replace x by negative x and y by negative y everywhere. Okay, in our algebraic relation here. So I'm going to be doing this. Okay. Okay, then let's clean it up. Oh, the double negative becomes positive. Let's box in our final answer. Hey, wait a minute. Did you guys notice? Hey, that's original. That's it. That's our original. That's exactly the same as the original. Okay? What I'm going to say here at the bottom is the relation has what we call origin symmetry. By origin symmetry, it means it's its own reflection across the origin. Okay? Now let's go ahead and take a look at these on Desmos.